Hey guys, Shravan here. Hope you are doing well. In this video, we'll cover multi-class classification using Tensorflow. Okay, let's get started. Okay, let's get started by creating a file for this problem, multi-class classification.py, and let's import all the required libraries to solve the problem: Tensorflow, NumPy, matplotlib, and last but not least, pandas. Now, as usual, like I have stored the dataset already into my GitHub repository. We will be solving iris dataset here, which has three class in this dataset. Previously, in the binary classification, we had only two classes, 0 and 1. In this dataset, we have three classes, 0, 1 and 2. So now we'll print so this is the thing, like sepal length, sepal width, petal length and petal width, and class. So as you can see here, class is not an integer but a string. So now we will convert this string into integer using mapper variable. Now we'll define that mapper. Mapper is nothing but a mapping between class and its integer value. So we'll do it a little dynamic way. Classes enumerate to get the index. Get the index. Write it. Index, and now let me update mapper with class and its respective value. So now we may ask why it will be like iris setosa, why it should be 0, why not 1 or 2. So to avoid this, we will confusion, we'll avoid we will one hot encode it for each for three classes. Now let's replace it and let's print it out how it looks. Okay, it's been converted to integer. Mapper has worked, and now let's do one hot encoding. Columns is equal to now classes. Class, yeah, class. Let's print its first few columns to just validate our work so far. As you can see, oh okay, something is wrong here. Class only one is okay, sorry, I. Now let's print it. Okay, yeah, now we can see like there are three classes here: class 0, class 1, class 2. So we have one hot encoded it, and the data frame, it looks like this. Yeah. Dummy class, we'll just initialize an array. We'll come to know why we do this thing. Multi-class class. So basically, dummy classes is a list of the column names that we just one hot encoded thing, and then now okay, let's remove unnecessary prints, and now splitting the data to train and valid. Let's do it by sampling it. So train df is equal to df.sample, and I'll take 85% as train dataset, and rest of the dataset will be considered as a validation dataset. We'll do that by remove dropping of the training index, drop, and we'll pass in the index of the train data frame. Now now we'll have to separate the labels, but here in this case we have 3 columns as the labels, so that is the reason why we above took an array of dummy classes is nothing but the list target columns. So now what we'll do, we'll concatenate by dropping each value, popping out each value, the column, each column dummy classes. So this will basically pop out and concatenate all the classes. So in the train levels we will be having a data frame of 3 columns. Something's wrong here. Yeah, I missed the array, sorry, braces here. Okay, now let's repeat the same thing for valid, or let's print it first before we move to valid labels. Okay, yeah, as you can see here, we have removed all the classes from the data frame target columns. Basically now we'll do df dot train df, that is train df, and valid df dot pop dc for dc in dummy classes access equals 1. Yeah, now it's been done for both train and valid labels. Now let's do scaling as usual. So if we just follow these steps, I think you can solve any problems or any data sets that you have with you. So let's do it for train df. So we'll subtract it with mean value and divide it by standard deviation. Stats of mean divided by stats of standard deviation. Let's repeat it for validation dataset. Valid df minus stats of mean, and let's divide it by stats of standard deviation. Okay, now this is done. Let's convert it into numpy array. Okay, sorry for that. Into numpy array, train data is equal to train df dot to numpy. Valid data is equal to valid df, same thing, to numpy. This they are done to convert it into Tensorflow dataset. Now let's define the function prepare dataset, or let's store the values for further prediction. Let me just okay, let's also do the conversion for labels, because this is also one data frame. In the previous case it was just column values. Okay, storing the dataset for future prediction. This is just an extra thing that I am doing here. Prediction data, we'll just take the first value, train df dot iloc, first row of the train dataset, result. Okay, 1 second. Valid. Okay, since we have not encoded it, it's not the same case like how we did previously. So let's 1 second. train. Okay, one valid datagram. So just let's take the first value, same way like how we did above. Dot ilog, pick the first column, sorry, first row. Okay, okay, let's do this. df, okay, df, okay, this is fine. Let's define the function to prepare datasets by passing in data, labels, batch size, and shuffle buffer. Data, labels, batch size, and here from TensorFlow, from tensor sizes, we'll be passing tuple, data, and labels. This is a convenient way to pass the dataset to training loop. So we'll see that in later part of this video. So basically, we don't have to pass two things like x and y separately. If we just pass a tuple for this from tensor slices like data comma labels, then we can just pass in this dataset. So TensorFlow inherently will understand like there is both x and y values. So now dataset, now we'll do batch, then prefetch, return dataset. Okay, now let's prepare dataset for training and validation dataset. Dataset, batch size will take it as 32, buffer is equal to 50, train dataset is equal to, prepare dataset, train data, train labels, comma, batch size. Just keep in mind that here train labels is not a single array values. It is a two-dimensional array. Like this, like it has 3 columns. Just keep that in mind. So train label, train data, sorry, valid data, valid labels. Okay, let's do a sanity test so far. Okay, everything has worked fine. Data preparation is done right now, till now. Now let's build a model. So there is a little change here again as compared to the binary classification problem that we did in the last video. Now let's again define a 3-layered model. Dense layer 512, activation value. This is similar to the previous one. Again, we'll define one more activation, dense layer with ReLU activation. And now is the change, like since we are dealing with 3 classes, we'll define 3 number of classes. Remember that we defined this above at the start, and we'll define activation as softmax. So softmax is basically like it will give 3 values from the prediction. So it will it's a probability distribution of each classes. So if you sum up all the value, it will come up to 1. So it's basically whichever class has more probability is what is the model's prediction. And now here for the loss we will be specifying categorical cross entropy instead of binary cross entropy that we used it for binary classification. Now optimization, same before, SGD. Now let's do a sanity test with just 10 epochs. Okay, it has run fine, no issues whatsoever. And also if you observe the MAE value, it has decreased over the time, over each epoch. So model is learning from each epochs. That's a good sign again. But let's not be satisfied with just this number. Let's also plot the graph of accuracy, MAE, and the loss function, loss graph. Let's do it the same way that we did in the last video. Plots, metric. So the key point here is to keep in mind about the loss function, optimizer, and then the last layer in the model. So it has a activation layer called softmax. It's basically provides a probability distribution of each class. So we will see that whichever has the highest probability will be treating it as that class, that particular class. So now we'll define epochs. Now let's plot it. Plot the graph with epochs against metric and epochs against validation metrics. Figure size 15 cross 10. Plot epochs, comma, metrics, label as usual, training, plot. Okay, training plot. And we'll do the same thing for validation metrics, epochs, validation metrics, and label. This plotting actually will give you a better insight of overall training process, because just by seeing the values that is there below, you will not get much idea. You may see like it is decreasing, but you may miss some values. But plotting graph will give you a good visualization of how this model is getting trained. Let's plot it. Okay. Also, there is a way of using tensor board. We will do that in the future videos. Okay, something is wrong here. Table spelling, as I said, bad end spellings. Okay, it has run fine. Okay, graph is also plotted. Accuracy plot. Okay, MAE has decreased, loss has decreased, fine shine, everything is fine shine. So our sanity test has been worked fine, without issue. Now let's do the prediction part here that we collected in the start of the video. Prediction. To do a sanity test, I will just comment on the show thing. I just want to have a look at the prediction data. Print a result. So result will be a 3 element array, a 3 sized array. As you can see here, total values. I'll just to value here, values, prediction data, dot values. Okay, it will give me an numpy array. I forgot to convert in the above, so let's do it here. Prediction data dot values, mp dot new axis. Again, as I said, Tensorflow model requires 2D array to be passed. Let's see it. Okay, yeah, it's fine. Let's convert the result to mp array. Result expected value, result, comma, prediction, np.argmax. So this is how you get the prediction. Like it basically gives the maximum probability distribution. So let's see what it has given to us. Okay, as you can see here, probability for the 0 class is more. So np.argmax will give like 0th index. 0th index will have probability compared to first and second index. You can just actually print it out and check yourself, like what is the distribution, probability distribution for each class. Now let's print for some more values. Okay, let's print it. Index. Let's just print for some more values. Okay. You can just do a for loop here, but I'm being lazy in this part. Let's check. This is just for 10 epochs, so let's see. 0 0 1 0 0 0 1 and 2. So there is one mistake in this. Let's see after doing a triangle for 100 epochs if it gives proper. Okay, still it's okay. If you can also observe that accuracy is only 90% here. Maybe that is the reason. Maybe we better have to increase the epochs number. Let's make a prediction for some more values. Let's see how good it is, how good the model is performing. You can also see from the graph and then the value here, 92% is the one is wrong here. So let's just train it for some more epochs. Let's increase the epochs number value. Okay, let's increase it. 110. Second. So something is okay. My system is kind of got hanged. Sorry for this delay. Sorry for the delay. So I think you can just try it out by changing the epochs value. Okay, it's back. Okay, maybe still 92%, so let's go to 150. Okay, now 150 for 150 epochs. Let's see, will the model predict correctly? Okay, see, if you can see the graph, it's still increasing, accuracy is increasing, so we can train more also. But yeah, here I think still there is a problem. Let's train it for 200. It's 94% accuracy for 150. Let's see for 200 what is accuracy. accuracy is again 94. Okay, build the model. Okay, still there is an issue. Okay, let's try it for 300. Okay, let's go for 300. Let's observe the accuracy value. Okay, it has gone past 95%. Okay, now it's 97.66. I hope it will be correct now. That's it. Yes, we have got it. So congratulations. We can go just to check if the accuracy is improving further. Last was 97. Let's see how it goes. Okay, nothing much has improved. It has flattened out. I think this should be fine, or it can improve further as well. So anyway, all the predictions are looking fine. I think we did a very good job. Let's wind up this video. Okay guys, I hope you guys enjoyed it. Next time maybe I'll look into it, what should be done. Okay, till then, thank you. Thanks for watching. Cheers. Bye.